So now that we have the measurements for the two lights on the front of the MOTOPED to get rid of that vibration from this leaf-on engine, we want to be able to draw that part up in a 3D program so that I can print it out on my 3D printer. And so what I'm about to show you is the program that I use to design the parts, walk you through the process and the steps that I use to create a 3D part. Then we're going to bring it over into what's known as a slicer, which will cut that 3D part up into multiple slices that the printer can print, and then I'll show you how it came out when we're finished.
So this is Autodesk 123 Design, and I'm going to use this. It's a free piece of software available online for designing 3D parts. I'm going to try to make my headlamp assembly. The first thing I know is that the platform is going to be 4 plus 2 plus 2. 4 plus 4 plus 2, that's 8. That's going to be 10 inches across. So I have to shoot over here and do my metric conversion, because all of those things are in millimeters on this side. So that's 254 millimeters. And the width is going to be 1.5 inches. So that will be by 38 millimeters. 38. Oh, too much. And then I'm going to make the height. What do you think a good height for that would be? It spans 8 inches, so I don't want it to be too flexible. So let's see. 1 inch would be 25 millimeters, and that's pretty thick. 3/4 of that would be about 19 or 20 millimeters. So let's go ahead, change that. That looks about better. And if I need to, I can always come back and put a steel bar across the top to make it more rigid. But for now, for supporting that, that's going to be just about right. Okay, so I've got that here, and I want to build up the I want to put a center line in so I can get some holes in from the edge. So I'm going to come up to here and project a plane, a sketch plane, on top of the box. So now there are lines here that the system can reference, and I'm going to sketch a line on this. So you'll notice as I hover across, when I get to the midpoint, it says, oh hey, here's the midpoint. And so I can pull this all the way down now and do the same thing. You'll see that triangle picks up and automatically snaps. Boom. There's my line. Okay, so over on my Amazon page, I know what the measurement of the, what do you call it, is the isolation rubber mount. And they actually give me a dimension here of 30 millimeters. So the center of the hole is 15 millimeters in from the edge. So if I give it a little bit of room from the outside, let's say I go 20 millimeters in from the outside edge, that would be a good place to put the hole. So I'm going to come back and sketch another line. So here I find that midpoint, and now I'm going to come out 90 degrees but 20 millimeters. And now I hit enter. So there's a point here, and I'm going to use that to drill a hole in a second, but I'm going to draw that line on the other side. So I'll pick that sketch, find the midpoint, and now again I'm going to come down 20 millimeters, 90 degrees. So now there's a point up here. Perfect. So this is an 8 millimeter hole, and I want it to have a clearance. So I'm going to type 8 millimeter clearance hole, and on the internet, let's see what I can find here. This is going to be an M8 fit class, loose, calculate. So I want a 10 millimeter hole. So I'm going to come over here and drill a 10 millimeter hole. So I'm going to do a sketch. Come over here, find my edge. Remember my point. Okay, and now I'm going to hit 10 for my diameter. There's my hole. I'm going to do the same thing over here. Excuse me. Edit the sketch. Going to find my hole. There it is. Pull it out, and now I tell it I want a 10 millimeter hole. Double click, and so now you'll see those are where my through holes are going to be on the 3D printed light part. Okay, so now what I'm going to do is I'm going to extrude those holes through there, but I'm going to edit the sketch and take away anything that doesn't need to be there. So this program doesn't want any lines around the holes when it goes to drill holes or create an extrusion through there. So now I'm going to extrude this face, and I'm going to go to that face, minus 20 millimeters, and hit OK. So now there's no hole, there's no material there. If you see, it's cleaned out that through hole, so the 3D printer won't print anything when we get to there. And now I'll do the same thing for this side. I'm going to tell it, hey, I would like you to extrude that hole to this face right here. I can see where the hole is going to be, minus 20 millimeters. Hit enter. Okay, so that's good. We've got our first two holes right here. Now, I know that I have a 1 inch by 1 inch by 1.93 mounting block. So I'm going to create a new sketch on the face of this. So imagine now that this face is where the lights are going to screw onto. It's upside down. Okay, so I'm going to build out the upper surface and get the mount correct for the through bolt to go through on the existing MOTOPED mounting angle that comes off the top upper tube there, right where the fork joins the body. Okay, but I know that that block has to be 1 inch by 1 inch by 1.93. So let's go in here and we'll sketch a polyline on top of this face. Now I'm going to find the midpoint, and it should snap. Yep, so there's the midpoint. And now I'm going to come across 90 degrees. And there's that 38 millimeter that we found. So if I come back over and just give it a quick look, that's halfway between the two dots. So that's good. We'll hit OK. Exit the mode. So now I'm going to create the block. So there's probably a better way to do this, and I'm not sure what it is. So I'm going to create a polyline. I'm going to click that sketch. There's the midpoint. Now I want to go out 1.93 inches divided by 2. So 1.93 inches is 49 millimeters. So let's do that. 49 millimeters divided by 2 is 24.5. So I want to go out 24.5 from the midline. So that's going to be as wide as my support block is on the one side. And so now we'll go out and we'll do the same thing. And we'll go out 24.5. So now that's as wide as my block is going to be that mounts this. That's what fits in the existing MOTOPED bracket. So we're going to now come up a ½ inch on each side. So let's go ahead and sketch that out. So I'm going to click, see if I can pick that line. Okay, here we go. So let's come out a ½ inch, which is exactly 12.7 millimeters this way. So 12.7. For some reason it's not letting me pick that point. So there it is, it's square. Come on. I'm not on this side yet. Oh, let's undo that. Try again. For some reason it's giving me a little bit of a problem here. So we'll come here. 12.7. Okay, so I've got that line. Now I'm going to come down from here all the way down. I should be able to pick that point. Yep, there's my 49. Now I can click here and go to here. 12.7. Now I can click here and come up 12.7. Now I can click here. Come down, tell it this is a corner that's important to me. It'll snap to that corner, I think. No, something's wrong. There we go. Alright, so there's my mounting block. And just like before, I need to extrude it. So I'm going to come up here and trim away everything that isn't what I want. So I don't want this. I don't want that, that, or this. So again, I know my block is 1 inch tall. So 1 inch in millimeters is 25.4. So I'm going to extrude this unit. I'm going to extrude that up 25.4 inches. Okay. So it's starting to look like a mounting bracket now. And there's a few things I need to do. First thing I need to do is put a mounting hole through here for the through bolt. So let's come over here and edit the face of this sketch right there. And I believe the through hole on there is also going to be, I think it's a 5/16/18 screw. So I want a 312 diameter hole through there. So that's going to be about an 8 millimeter hole. So if I made it 10 millimeters, it would be fine. Actually, it says here the hole is 290. It's a 290 dimension. I measured that hole. So 8 millimeters through there, I'll be fine. And it's down, it's up from the bottom 1/4 inch. So I'm going to come over here, draw a line, find my midpoint. So I pick that surface for a sketch, hit OK. Got a little happy. Click to specify the first point. That's what I'm trying to do. Oh, it didn't pick the right sketch. Let's try again. There we go. Okay, so I'm looking for the midpoint. Man, it's getting hard to pick that. So let's go here, do it again. That looks like the midpoint. And come down. Half of 25 would be 12. 12.5. Okay, so that's where, that wasn't even in the center, was it? All right, we'll undo that. I don't know why it's not letting me pick that, but I'm going to try again. One last time. Okay. There it is. So now that's where the center line of my hole should be. I think I want it to be a little shallower than that. I want to get it up so I can actually rock that bracket. So I'm going to make it 10 millimeters. Let's undo that last thing here. Let's come down 10 millimeters. That looks about right. Okay, now I'm going to sketch a hole on here, right on that plane, and the diameter is going to be 5 millimeters. Whoops, that didn't look right. Hole diameter is going to be 10. 8. We said 8. I can always make it bigger. Okay, so there's my hole, and I'm going to come in and delete all the other sketch lines that don't need to be there. So that line, okay, we're good. Now I'm going to extrude the hole out through the other side, so I tell it, hey, that's the direction, that's the profile I want to use, and I want to come all the way through. There's my -49. Okay, so now it's starting to look like a bracket here. Okay, so I'm going to come in and delete all those sketches that are on there, and to do that I click on this and I click move, and see how when I pull that up, all of those sketches, I came up 100 millimeters, and now all of this crap, I'm going to take it here. Now I'm going to move it down 100 millimeters. Whoops. Let's try that again. This one. -100. Okay, so that puts me back where I am. So one of the first things I want to do is I want to put a fillet on here because I don't want these sharp corners. So I think there's a modifier on here that lets me, yep, I can put a fillet here on that edge, and let's try a 10 millimeter radius. Okay, that works out good. Matter of fact, let's go 9 just to make it shallow. And I'll flip it over and I'll do the same thing on this side. And pick this one right here. And we'll tell it to use a 9 millimeter radius. Okay, so now I've got a really cool bracket. If I printed it just like this, it would fit right in the existing MOTOPED hole, and I could mount the 2 isolation mounts right there and be good. So one of the things I'm going to do now is I'm going to just clean it up a little bit. I want to just clean it up a little bit. One of the things I can do is round off some of these corners. So just to see if this is going to work at all, let's go ahead and modify these 4 corners. Let's go ahead and tell it to put a 5. Nope, that's shallow. Let's put a 10. 10, that's getting better. Let's go 20. 20 is pretty darn good. So what's 19 look like? 19 is perfectly round. Okay. So we'll put a 19 millimeter radius on that and hit OK. And so right now, if I went to put this on the bike, I would mount that in the existing lamp holder. I would mount those isolation rubber mounts through those holes, and I would have a light sitting just above on either side of the center wheel right there. The only other thing I might want to do is put some kind of material. Right now I'm using a lot of plastic to print that, and this is looking like it's going to be pretty rigid enough for most of what I'm doing. So what I'm going to do now is I'm going to put a few lightning holes on either side of this, just to see what that would look like. I'm going to make them 75 millimeters. That's the way I want to do it. By 10. How about by 5? By 200. No. 100. How about by 50? Okay, so let me see if I can pull that over. I just want to see what it would look like if I cut that distance out a couple times through here. So that's definitely a little too long. So let's go ahead. I don't know if I can change that. Yep, so I can go 10 millimeters that way. And now let's see if that would be a nice cutout. Yep, so if I cut that out on either side of the hole, or even 3 times, it would take out some of that material in between, and it would still be rigid enough for those lights. So let me see if there's a way to align or copy that. Can I scale, smart scale, move, material, export, send to mesher, send to 3D print, send to make? I think I would have to duplicate it. Path, circular pattern, rectangular pattern, or mirror. You know what? Let's come in here and tweak it. We'll pull this out 8 millimeters. And now what I'll do is I'll come here, and it doesn't have to be perfect, but I want to align the 2 parts if I can. I'm not sure if there's a way to do that. There's a way to center those 2 parts. So let me see if there's a way. If I highlight both of them, can I scale? Grouping. I don't want to group it. I don't want to combine it. I don't want to measure. I don't want to text. I just want to align those 2 things. I don't see a tool that lets me do that. So that's about as far as I can get it to square. You see what I'm trying to do here, right? I just want to cut out some material so it's not so heavy of a part. So what I think I can do now is I think I can subtract that. And let's see if there's a way to do that. Combine, merge, subtract. Select a target solid mesh. So that's going to be my target. And now that's what happens when I take it away. So that'll actually work. Let's measure those dimensions because I want to do that on the other side too. So measure that edge was doesn't tell me. Oh, here we go. Measure distance. I don't remember what the size of that thing was. You do because you just watched me do it. So let's go ahead and create another box. I think we said the length was 75. It was this way. 75 to start. I think it was 10 millimeters that way, and then we went 50 up. Okay, does that look about right? Nope. So we definitely tweaked it. Let me find a way to measure that again. I wish I knew how wide that was. $13 millimeters. Okay, so I know the box is at least 13 millimeters, and let's see if I know what this one is. That one is 65, so it's 13 by 65. We can delete that. So one more box. 13. Whoops. 13 by 65 by 50. Okay, so I can get rid of this box. Don't need it. So now I'm going to do the same thing I did on the other side. I'm just going to eyeball it. Again, that's not a critical dimension. I just don't want to burn up all the plastic making that part. And so if I get it as close as I can, that's about as far as it was on the other side. It's about as far as it was here. It looks like top to bottom I can come up just a hair. Let's see how that looks. How's that look to you? Look okay. It looks like it's a little closer to the hole. So it was a little closer to the hole on the other side. That's pretty good. So let's go ahead and subtract it and see how it looks. So I'll come over here, merge, subtract. This is my final. This is what I'm taking off. And so now, now I've got a nice bracket here. And so just because this is a part that I want it to be nice and strong, I don't want it to crack, I'm going to come in here now and create some more fillets. Hold my control key down. I can pick multiple lines at the same time. And my radius, let's try 5. 5 is pretty good. Let's do the same thing over here. We'll modify it. And we'll pick the first one, control key the rest of them. 1, 2, 3. Now check it down here, hit 5. Okay, boom. And that'll be good there. So to make it a little cleaner even, it's going to print this way. It's going to be flat on the bottom. I'll come over here and I'll choose one more fillet all the way around on the outside edge. And I can start with like a 2. And you see here it's got a nice rounded edge to it. And I can do the same thing over on this part here. Whoops, making myself dizzy. Alright, so we'll do a fillet on this side too. Let's pick that. We'll also do a 2. Come over here on the other side. We'll also do a 2. And we'll do one on the inside here. Again, round edges add strength. Square edges, you get cracks. So anywhere I can put just a nice transition right here, and I'm going to do the same thing on the other side. So we'll just cha-cha-cha our way around that here. One more time, and I'm just gonna pick a 2 all the way around here, here, and here. Okay, so now I've got a really nice mounting bracket here for those LED lights. If you flip it upside down, that's what's going to drop into the existing MOTOPED light holder. I'll put the screw through there on the bottom through this hole and lock it down, and then I'll have the 2 isolator rubber mounts up on top of here. Those lights will be nice and high, and I'll be able to turn them and aim them and direct them there. So let me export this part, and I will show you how I bring it over into the 3D printer here next. Okay, so now I need to export this as a printable file. I'm going to export it as the finest mesh I can, and we'll call this MOTOPED dual light bracket. We'll save it on my desktop. Okay, and now I'm going to bring it into my slicer. This is the program that will slice it into layers that the printer can print. Okay, so now that's what it will look like on my printer bed when it's finished, hopefully. Knock on wood. Let me set the printer up. I'll take some video of it running, and then I'll show you the part when it comes out. So we've got the file out of the computer and over to the 3D printer, and I just wanted to walk you through some of the stuff involved with that so you can see the process. The 3D printer has a roll of plastic on here. This is ABS plastic. I can also use
a multitude of other materials, including things like PLA, nylon, and so forth. This is a TAS 5 from Aleph Objects in Colorado, a company called Lulzbot. And right now we'll try to get this a little closer so you can see what's going on here. And there's a print head that's melting the plastic and depositing it in small layers, layer by layer, until we get the form that you see here. So as of this point, it's already printed the part that we've created on the CAD program, and that CAD program sliced it then in the slicer into hundreds of individual layers. And now as the part is printing out, the print head is moving higher and higher each level until we get the part that you see here. So this thing has taken about 7 or 8 hours to print, and right now it's printing the mounting assembly. It's actually printing little support holes where the through hole is going to go for the MOTOPED bolt that used to hold the existing LED light on. And in the morning, when I come back up here, this part will be finished and ready to peel off of the plate. And so I'll be able to take it off and mount it on the bike, and then dry fit the new LED lights to the bike and see how that looks.
So it's the next morning. I've gotten up early. We're going to check on the wild 3D printer to see if the part has been made properly. We need to enter the room as it's dark and surprise the part on the printing bed to see if in fact it has been made properly. It's like Christmas when you come in the next morning after the part has been made to see if it's been made. And there it is. So what was on the screen is now in my hand. And that is pretty awesome. Super lightweight, very rigid, and with a little sanding and a little finishing here, that part is going to be amazing. So there are the slots that we made. There's that nice radius that we put on the program. We've got those 10mm holes for the 8mm through bolts, where our rubber mounts are going to sit, and then our lights will sit on top of that. And then we've got the through hole with the 1/4 inch offset on the bottom that'll clamp right in that existing spot where the cheapy MOTOPED headlight was. And this should really do the trick. I'm very excited about this. So let me wrap this video up. We've made the part. Next I need to draw and print out the center console so I have some place to put my light switches, and then that 12 volt voltage display so I know if the voltage regulator is working. And that'll be a separate video altogether. So I'm going to go back. I'm going to 3D print the console, and we'll start putting everything together in the next video. But I couldn't be more happy with these results. Absolutely fantastic. It looks like we might be turning a corner on the MOTOPED finally getting it up to a reasonable level of quality. I'll share some thoughts too also on the carburetor. I've had some really great success with TB parts and their new carb that they sent me with the jet kit. But for now, man, what a way to start the day. Fantastic.